Moving on to problem number 3. Once again, all we're going to do is do the setup, and then we'll come back to these problems and continue them from there. Alright, so problem number 3 says a 15 kilogram box is resting on a 32-degree incline and accelerates down the incline at 0.3 meters per second squared. Find the friction force impeding its motion. What is the coefficient of friction? Okay, so what do we have here? We have a box. It's released on an incline and it accelerates down the incline at a certain acceleration. Okay, so let's draw our free body diagram. Okay, so now that we have this, what are the forces acting on the box? Well, first of all, we always know that there is a force due to gravity acting on the box. And there's going to be the normal force, right? What else do we have here? We know that's just being released. And it's sliding down the incline, right? Okay, so that being the case, are we pushing on the box? No, right? So if it's sliding down the incline in this direction over here, well, first of all, that's the direction that we're going to say is our positive direction, and then this over here will be our negative direction. Being that it's sliding down in this direction, that's going to be our positive direction. So, what are the forces acting on it? Is there any friction acting on it? Is the frictional force that is acting on it, is that helping its motion or impeding its motion? It's impeding the motion, right? It's kind of resisting the motion. So that being the case, would you actually say that it's the frictional force is acting upwards or downwards on the box? Well, if the frictional force is acting downwards on the box like this, that would actually indicate that's helping out the motion of the box, which we know is not the case. But if it's acting upwards on the box like this, then we know that that's actually impeding the motion of the box. It's resisting the motion. So this is our frictional force. Being that we know that the box is actually in motion, what would you say it is? Is it kinetic or static friction? Hopefully by now you're saying it's kinetic friction. Are there any other forces acting on the box? No, right? Once again, being that we are defining that these are our positive directions, we tilt our head and we look at this as going straight up, this one's going to the right, and this one's going down and to the left. That being the case, let's draw our component vectors. Being it's going down to the left, we're going to draw our down arrow and our left, component vectors. And we know that the angle in here is 32 degrees. And this is once again FGY and FGX. Okay, so let's pull out all of our given information. What is this 15 kilograms telling us? And it accelerates at 0.3 meters per second squared. Hey, you know what? That's our acceleration, right? And that's our acceleration in which direction? Okay, and what are we trying to find here? Find the friction force impeding its motion. Okay, so it sounds like that we're looking for Fk. What is the coefficient of friction? Okay, so we're also looking for mu k. Alright, now let's write out our two force equations. Okay, and once again, all we're going to do here is this. We're going to lay down our pencil, and we're going to lay it right on our free body diagram. What we're going to do here is scan, and look for all the forces that are going in this direction. So I see that the normal force is acting in this direction. And that's the positive direction, right? Anything else? Oh, I see that in this direction we have FGY. So we have minus FGY. Is there anything else? We're going to scan. No, nothing else, right? Just FN and FGY. Question for you. Is the box moving in this direction whatsoever? No, right? It's sliding down. So that being the case, what's the value of our AY? 0 times any number is equal to 0. Okay, and let's do the same thing for all the forces acting in the x direction. So this is our positive x direction. So lay your pencil down like this and scan the free body diagram. So let's scan our free body diagram. What forces do we have? Oh, we have FGX. Do you see that? How FGX is going down in the positive direction like that? So we have FGX. Are there any other forces acting in this direction? No. But we do have FK, our kinetic friction, in the opposite direction. Okay. And those look like the only two that we have. Now, is the box moving in this direction? Well, yeah, it's sliding down the ramp. So therefore, we do have an acceleration, and we're being told what the acceleration is. It's 0.3 meters per second squared. So all I'm just going to do here is just drop this down. And we have our setup for this problem.